Hey everyone, we're back with similar polygons today. So what a similar polygon is are things that have the same shape but not necessarily the same size. So think two things that look exactly the same, but one is smaller or larger than the other. Okay, now we've got a definition here that's really important to understand. Polygons are similar if and only if their corresponding angles are congruent and the corresponding side lengths are proportional. Now when they talk about corresponding, they mean as you go around this figure, they are the angles or sides that would be considered the same ones if they enlarge these figures. Okay? So if you look at this figure here, we've got some similar figures, similar quadrilaterals. These are four-sided figures. And we've got what's called a similarity statement. So ABCD is similar to RSTU, and this works similar or the same way as a congruent statement. Okay, so they're telling you that angle A and angle R are your similar angles. Angle B and angle S are your similar angles. C and T are similar, and D and U are similar. And since they're angles, they have to actually be congruent. Now, the other one is AD. Okay, if you look here, these are the first and last, and RU, first and last, have to be proportional. Now, since they have to be proportional, you see that AD is 1, RU is 2. That is a 2-to-1 ratio. And so if you work around this figure, AB is 5, RS is 10, that is 2-to-1. BC is 2, ST is 4, 2-to-1. DC is 3, UT is 6. Again, that's 2-to-1. That's what has to happen for these things to be similar. So they must follow a common, what we call a scale factor. And that's right here. So the ratio of the lengths of the corresponding sides of two similar polygons is called the scale factor. And this depends on the order of the comparison. Okay, so it's really important to understand the order of these things and how they go. So if I were to take this one first, we'll call this figure A, we'll call this figure B. If I'm looking at the scale factor from A to B, okay, well A has a ratio from 5 to 10, and remember we reduce this, so 1 to 2. Now if I reverse this and I go from B to A, using those same sides, I'd have 10 to 5 or 2 to 1. So depending on the direction that this thing goes, I could say it has a scale factor of 1 to 2, or I could say it has a scale factor of 2 to 1. Okay, and that's important to know if it's growing or getting smaller. Alright, so let's see how this works. A company wants to build model cars based on full-size cars. Question is, are the cars below similar? And if so, what's the scale factor? Alright, so let's check it out. So here's the two cars. I got a model car that is 10 inches long, and the full-size car is 180 inches long. Okay, so if we take this and we think of it as model over full, I've got 10 over 180, and if we reduce that down, I get 1 to 18. Now for this thing to be a true model, or a true similar figure, it has to be the same for all dimensions. So I now go to the height. Okay, the model is 3 inches tall. The regular car is 54 inches tall. Now we take that, we set that up as a ratio and reduce. Well, 3 goes into both of those, and that reduces down to 1/18. Now since they're both the exact same, you can say that they are similar, and that 1/18 is the scale factor. Alright, so how can we use this to solve polygon figures? Well, we've got this. In this diagram, ACDF is similar to VWYZ. Now understand this figure may have been rotated, so this similarity statement is very important. I want to know what is X and Y. Alright, so let's think about what we know. We've got AF. AF is 12, and AF, if you look at your similarity statement, is the first and the last. So the first and the last in each of those are similar. So AF is similar to VZ, which is here and here. So depending on the way you want to write this, I can put either one first, but we'll put 3y minus 1 over 12. Okay, those are my corresponding sides. I'm going to put them as a ratio. Then I look and see what else I have. Well, I've got CD. CD are the middle two. That one's 9, which means I have WY, which are the middle two, which are 6. Now remember, we took our smaller figure and put that in the numerator, so that means 6 goes in the numerator, 9 goes in the denominator. And what we now have is a proportion, and we talked about proportions last time. So we cross multiply. So you've got 12 times 6, which is 72, equals 9 times 3y minus 1. Now you have to remember to distribute. So 3y times 9 is 27y. Negative 1 times 9 is a negative 9. And then you go through and solve. So we're going to add 9 to both sides. That gives you 81 equals 27y. Then 81 divided by 27 is a y value of 3. And there you go. There's your first one. Now the other thing we're asked to find is this x. Okay, so there's x. Excuse me. So x is df. That corresponds to yz. So x corresponds to 10. And so we can set that up as a ratio. So I've got 10 over, or I'll set this up as x over 10. Okay? Now remember, we put x in the numerator, so that means between these two, which we used as our scale factor before, the 9 is now going to have to go in the numerator. And your 6 is the denominator. Okay, from here, you cross multiply. 10 times 9 is 90. 6 times x is 6x. You take your 90, divide that by 6, and it gives you an x value of 15. And there's your x. So x is 15, y is 3, and there are your two solutions. Okay, using that, if you would, pause the video, give this example a try, and come back in just a minute. Alright, let's see how you guys did. So, in this figure, we've got JLM similar to QST. Now, in this one, we know what JM is. JM is 4, and that's your first and your last. So we take our first and our last here, and that's QT, and QT is 2. So what we're going to do is we're going to use JM and QT, which are these two, as our scale factor. So 2 over 4, or you could even reduce that down to 1 to 2. And then we just go from there and start figuring out these values. So the first one I'm going to work on is this x. So I've got LM. LM is 6x minus 3, and LM are the last two, which means they are similar to ST, and ST is 3. Now remember, since we put 2 in the numerator in our scale factor, the 3 has to go in our numerator in our problem. So I've got 3 over 6x minus 3, and now we just solve. So cross multiply. When you cross multiply, you end up with 6 equals 6x minus 3. Add 3 to both sides, you've got 9 equals 6x, which means after you divide, x equals 9/6 or 3/2. There's your first answer. Now the second one, I'm going to use the exact same 1/2 scale factor. Okay, that leaves me with this 3y minus 2, which is LJ. Okay, and go back up here to our similarity statement. That's the first two. That means that it's going to be similar with QS. So I've got QS, which goes in the numerator of 5. JL is 3y minus 2, and solve from here. So again, we cross multiply, which gives you 10 equals 3y minus 2. Add 2 to both sides, so 12 equals 3y, and then divide by 3, and y equals 4, and there are your x and your y values. Alright, hopefully that makes some sense. Final thing, we have a theorem. It's called the perimeter of similar polygons theorem. And this is any polygon, not just quadrilaterals, triangles, pentagons. It's any polygon. Okay, so if two polygons are similar, then their perimeters are proportional to the scale factor between them. Now remember, the perimeter is the distance around a figure. Alright, so let's see how this helps us. It says, in the diagram, ABCDE is similar to RSTUV. Find the scale factor and the perimeter of each polygon. Alright, so for ABCDE, we know CD. CD is right here in our similarity statement. If we compare that to the second similarity statement, it is TU, and TU is 21. So those two are the corresponding sides. Now if you set that up to find the scale factor, you've got 7 over 21, which is 1 to 3, or 1/3. That's your scale factor. So we know right away what our scale factor is. Now we're going to use that to solve for the perimeter. So we use our scale factor. That theorem says that the perimeter of the smaller one is proportional to the larger one, okay, in relation to the scale factor. So we need to find perimeters. Well, for this first one, A, B, C, D, E, we don't know it. We just call that X. For the second one, we do know this. We can add all these together. So I take 12 plus 19 plus 27 plus 21 plus 35. Add those all together and we get 114. That's my perimeter for that pentagon. And now you just cross multiply and solve. So 3 times x is 3x. 1 times 114 is 114. You take 114 divided by 3 on both sides, and you end up with x equals 38. So what that means is the perimeter of that smaller pentagon is 38 all the way around. Okay, so there are some examples and some theorems with similar polygons. If you have any questions, please contact me online. Otherwise, good luck with your assignment, and we will talk to you soon.